This is the fourth video of the series about pfSense and UniFi Layer 3 switches. In previous video, we discussed the scenario where you have two UniFi Layer 3 switches in your pfSense setup, and your inter-VLAN routing works in both switches internally and between the two switches. In this video, let's expand the scenario by introducing a new VLAN, which is managed by pfSense instead of by the UniFi switches. I believe this is the most common scenario in most people's setups. This is my lab environment. I run pfSense on a mini PC. The one part is connected to my home network for internet, and the first UniFi Layer 3 switch is a 24-port USW Pro switch. The second one is a 24-port PoE switch. It's in the enterprise product line. Yes, it supports Layer 3 routing. Based on what we already configured in previous videos, we will create a new VLAN, VLAN 10 here, managed by pfSense. We will SSH to the two switches to check the backend settings, and we will see whether any additional settings are required in pfSense or in the two UniFi switches to make everything work. Let's first examine the existing VLAN configurations. In pfSense, go to Interfaces, VLANs. You can see there's only one VLAN configured, VLAN 4040. It is used for UniFi inter-VLAN routing purpose. In UniFi Network Controller, go to Settings, under Networks. Now we have 6 networks configured. For the first one, the default network, for the router column, you can see it says third-party gateway, which means pfSense in our case. The second one is the VLAN 4040, which we just saw in pfSense. The remaining 4 VLANs are managed by the two UniFi switches. They are not maintained by pfSense. Now we are ready to create the VLAN 10 in this diagram. Let's go to pfSense, click Add to add a VLAN. Make sure the parent interface is LAN instead of a default WAN. For VLAN tag, it should be 10, then save. Go to Interface Assignments. In the available network parts, choose the VLAN 10 we just created. Click Add. Choose the OPT2 interface. Enable the interface. I don't like the default name. Let me change it to VLAN 10. Then the IPv4 configuration type. Let's choose static IPv4 and scroll down for IPv4 address. Let's give it a subnet 10. Subnet mask, of course, 24. Save. Apply changes. As you can see, this is just regular pfSense VLAN configuration, right? Nothing special. It has nothing to do with UniFi Layer 3 switches. Then we need to enable DHCP service for this new interface. In this video, we will still use pfSense DHCP server instead of DHCP relay. In next video, I'm going to talk about DHCP relay option. Let's go to Services, DHCP server, then click on VLAN 10. Let's enable the DHCP server. For the range, let me set it as 100 to 200. Okay, save. Now we are done with the pfSense side setup. Let's move on to UniFi Network Controller. In Network Settings, click on Create New Network. So let's give it a name VLAN 10. For the router, keep it as third-party gateway, which is correct because we want it to be managed by pfSense instead of by these two UniFi switches. For VLAN ID, it should be 10. Add network. The next step, we need to make sure this Linux number file machine belongs to the new VLAN 10. So we need to change the port profile in the first UniFi switch because, as you can see, I connect the Linux number file to the first UniFi switch. Go to Devices, choose the Pro 24 switch, go to Ports, click on Port Manager. As you can see, the port 12 here is showing just one Linux machine as the client, and the one showing here is not really the Linux number file. That's because I have multiple Linux virtual machines connected to the same port. Because I'm using the same physical port to connect to multiple virtual machines, and I cannot simply set the port profile for this one to VLAN 10. So the only way to resolve my issue is I need to go to my EXXI, which manages my Linux virtual machines, to assign the VLAN ID there. Of course, in your situation, you don't need to do that. It's just in my particular situation, I have too many Linux virtual machines. I have limited network ports in my rack mount server. So that's why I have to take this workaround. This is the EXXI I used to manage the virtual machines in this video. I created a port profile for VLAN 10. The physical adapter is connected to the physical port you just saw in the UniFi network controller, but I assign the VLAN ID 10 here, and I have this Linux number file connected to the port group. So in this way, I reuse the same physical port, but they can serve different VLANs. So you don't need to care about the details. It's just for your information how I work around the issue in my setup. Because I changed the network adapter setting for this Linux virtual machine, I need to refresh the DHCP. Let me go to the setting, enable the wired. Okay, now it get IP address already. Let me validate the IP address. As you can see, the subnet is 10, so we are good. Now this Linux number 5 virtual machine, it belongs to VLAN 10, which we just created. So far, all the configurations we did were all the routine VLAN configs in pfSense or in UniFi network controller. Nothing interesting and nothing special. Let's see whether VLAN 10 can already communicate with other VLANs. Let's try to ping the Linux virtual machine in VLAN 141. Let me go to Linux number 4, get the IP address first. Okay, it's 141.6. Then from the Linux number 5, which is in VLAN 10, let me ping the Linux number 4. No, it doesn't work. Why? It must be due to firewall. So let's go to pfSense Firewall rules. Click on the VLAN 10. It is empty. No wonder the ping didn't work. So let's add a new rule. The action is pass and the interface is VLAN 10. Protocol, let me choose any. About source and the destination, of course, we can simply say any to any. It's guaranteed to work. But for better understanding, we want to find the minimal rules. Let's try it. For source, let's say VLAN 10 net. For destination, I only want to enable the VLAN 141. So if I pull the drop down, I don't see VLAN 141. Why? Because it's not managed by pfSense. So how we can specify the VLAN 141 subnet? We simply say network. Then here we have the chance to specify the subnet. So let's use this subnet information. Subnet mask is 24. Okay, we are good with this source and destination setting. Let me save it, apply changes. See the Linux number 5, even without doing anything, it's automatically reaching the destination. Now the ping works. To understand the routing, run this traceroute command. It needs to reach the gateway for VLAN 10 for the first hop, right? No problem. And then for the third step, it needs to reach the subnet 141. But if you check the second row, go via VLAN 4040 network. But we didn't add a firewall rule in VLAN 10 to enable it, right? However, if you think about it again, you can realize the second hop happens on another interface in pfSense, the VLAN 4040 interface. instead of the VLAN 10 interface. So even if a firewall rule is needed in pfSense for the second hop, the rule should be defined in VLAN 4040, right? If you watch the second video in the series, for the scenario where we only have one UniFi layer 3 switch in pfSense for VLAN 4040 interface, we did create a firewall rule already. So now let's check it in pfSense. Yep, we do have a any-to-any rule defined here already. To make sure our theory is correct when it comes to this particular rule, let me disable it. Now let me go back to the VLAN 10 Linux. Let me ping the exact same IP address again. Interesting. See, the ping still works. We thought without this firewall rule in VLAN 4040, the ping shouldn't work, right? But now it does work. I will explain the reason later. Before doing that, let me do the ping in another way. See here, I'm pinging from the VLAN 10 to VLAN 141, right? Let me do it the other way. So from the VLAN 141, let me ping the VLAN 10 machine. See, this one doesn't work. If I enable the firewall rule for VLAN 4040 again, see, right away it works. Both directions work. You already know the conclusion, so the VLAN 4040 rule is required to make the communication work. But why, even without it, just one direction works, the other direction doesn't? To understand why the different behaviors for the two different pings, we need to understand how the pfSense rules work. So I'm showing you a pfSense official document for firewall rule methodology. So the first paragraph is exactly about our situation. Rules are always in the inbound direction on the interface. For outbound directions, it's automatically allowed. And because all rules are stateful, a state table entry is created when traffic match an allow rule. So which means all reply traffic is automatically permitted. This is also important to understand our situation. So let's use this diagram to explain the two different pings. First, let's check from the VLAN 10 machine. We ping VLAN 141 like what we did here in this Linux number 5, right? So the ping is from the VLAN 10 machine. For the traffic to come into pfSense, it needs a firewall rule to allow it. And this particular interface is VLAN 10, right? That's exactly why we need a firewall rule in pfSense for VLAN 10 to allow this traffic. See, the source is from VLAN 10 net, and the destination is this particular subnet, right? That's exactly what this firewall rule allows. Okay, we are good about this part. Then the traffic need to go from pfSense to the second UniFi switch. And this is done through the static route. So let me show you the static route, which we defined in previous video. The destination is this network, 141 network, and it's through this VLAN 4040 interface, right? So this is static route, and the direction is from pfSense to outside. This is outbound traffic, so this traffic is automatically allowed. We do not need a firewall rule. So we are okay till this end so far. Then for the traffic to go from the UniFi switch to the target Linux machine in VLAN 141, because it's within the UniFi switch, this particular part doesn't need firewall rule. Okay, we are good. So the traffic arrives at the destination, the VLAN 141 Linux. But for the response to go back to this VLAN 10 Linux, let's see whether it's possible. So from this VLAN 141 machine back to the UniFi switch, no problem. It doesn't need firewall rule. For the traffic to come back from the UniFi switch back to pfSense, all reply traffic is automatically permitted. So for this particular part, it also doesn't need a firewall rule, even though it is inbound. So that's exactly why in our testing for the VLAN 4040, even if we disable this firewall rule, the traffic can still go back to pfSense, because for this particular case, we do not really need a firewall rule on VLAN 4040 interface. Okay, we are good at this point already. And then the last leg is from pfSense back to VLAN 10 Linux, right? For this outbound direction, it doesn't need firewall rule. So that's why even without this VLAN 4040 firewall rule, from this Linux number 5, we can always ping the VLAN 141 Linux without problem. I hope it's clear about this particular ping. Now let's check the second ping. So from this Linux number 4, the VLAN 141 Linux, why it cannot ping the VLAN 10 Linux successfully if we do not have the VLAN 4040 firewall rule, right? So let's check it step by step. From this Linux to UniFi switch, okay, no firewall rule is required. And from the UniFi switch to pfSense, this is inbound, and this is on the VLAN 4040 interface. For this particular traffic, it does need a firewall rule to allow it. So that's why if we disable this particular firewall rule for VLAN 4040, this ping won't work, simply because this particular step is not allowed. Right after we enable this particular firewall rule for VLAN 4040, this leg is possible, and then all others are also possible as well. Okay, I hope this particular interesting two ping situation help you understand in what situation the firewall rules are required and for which interface. Because in this example, we are talking about two different interfaces. Of course, the firewall rules for VLAN 10 may not be enough in real world. For example, it cannot access internet. But that has nothing to do with UniFi layer 3 switches, so I will not talk about those type of firewall rules in this video. Now let me SSH into the two UniFi switches. Make sure you read the notice and only proceed if you decide to take your own risks. Let me run show IP route. So if you compare this result with our previous two UniFi layer 3 switch results, you can see there's nothing new. So the introduction of the VLAN 10 managed by pfSense doesn't impact the routing table within UniFi switch. This is expected. In this SSH, let me run another command, show IP interface brief. It also doesn't show anything interesting about VLAN 10, which is also expected because VLAN 10 is not managed by these two UniFi switches at all. So then let me run show VLAN in both switches. Okay, this time you see all the VLANs, including the default VLAN 1 and the VLAN 10, because we define them in the UniFi network controller, right? Basically, this means these two switches, they are aware of the existence of VLAN 10, but they don't care about the routing details about them because the existing information is already enough for them to route the traffic to pfSense and let pfSense take care of the routing for VLAN 10. Okay, so this part is very short and very simple, and we are at the end of this video. Thanks for watching.